Let's take a look at Maya's closest point constraint. The closest point constraint is used to track points along a NURB surface or polygonal mesh. What this does is it creates the closest point on surface or mesh node and ties that to the object you constrain to. Let's go ahead and take a look at what's happening in this scene. I'll go ahead and hit play. You'll see that the surface has a wave deformation, but our character interpenetrates through the floor. So we can use the closest point constraint to correct this. Making sure we're under the animation module, which is constraint, and here we find it the closest point constraint. We could take a look at the options. So resetting the settings, you'll see that Maya is going to create an input position locator and a closest position locator. Let's go ahead and select our floor, choose apply, and take a look at what this means. All right, so if we were to now scrub through the animation, you'll see that there is a locator now glued to our surface, almost as if it were geometry constraint. We get the same type of effect, only with the geometry constraint, it does not come with an extra locator that we can use to move the position, to offset the position of our constraint locator along this surface. So what I'm doing right now is selecting CP constraint in, which is our input locator. Now, what is this driving? What is this CP constraint in node actually doing? Well, let's go ahead and take a closer look. If we were to select our surface, we can now move over to the attribute editor. From there, you'll find the closest point on mesh node. So here's what's been locked down. With this node, we're given an in position that we can use to modify an object's position as it travels along a surface. Right now, we cannot change any of these values because it's tied down by the locator we've created to control those values. So you can see as we start to pull the constraint in node, our closest point on mesh input is also changing. Now, if we had not created that node, we have the choice of not building it. If we were to turn that off, we would then have full control over each field. If we do not use any option, Maya will still create the closest point node. Just to show you this, I'll go in and quickly create a NURBS sphere. Now, let's go ahead and choose the closest point option with nothing on. We'll just choose apply and close. You'll see that now Maya has created another closest point node, but this time it's a closest point on surface node because we're dealing with a NURB object. Okay, but also notice there's no extra locator added. So it's just a quick way of building that type of system. We can now go in and delete our sphere. But again, the locator behaves like a geometry constraint. If we were to grab our floor and start to move that around, notice the locator will never separate from the mesh. And it's only being driven in its position. So we can rotate the surface however we like, and only the position is going to be modified. All right, so again, we're going to use this to finish this project to make sure that the character does not interpenetrate. So first things first, let's make sure that our locator is at the origin or zeroed out. You can double check this by making sure that both your input locator and your constraint locator are set to values of 0. They're translate channels. Now, let's go ahead and head over to our character node. Let's go ahead and expand it. And we'll want to connect in our global control. But more importantly, we're going to want to create a group node above it. That way, our character can still translate across the surface while having the character still constrain to the surface to avoid interpenetration. Now, in order for this to happen, I have altered the global control somewhat. So this rig uses our character rigging for production asset. And one thing that's a little bit different is you'll see that the global move node, all of its connections have been removed. They were once connected using the connection editor to our global control curve. But in this case, I've just removed those connections and parented the node directly to our global control curve. So that will assure that when we connect the position of our global control, everything will still transform properly. Our character will travel along the surface as he needs to. If we don't do that, well, it's going to require more effort to get the solution working for us. All right, so let's go ahead and finish up. All we'll need to do is grab our global control curve, group it with a world group, simply using Control G. Notice that the position of the group is right on top of our locator. That's exactly what we want. That way we can do a quick point constraint. All right, so going back to our group, might be a good idea to rename it. So we'll call this GRP CNS, since it holds a constraint or will hold a constraint, underscore global move 01. Okay, so at this point, it's just a matter of grabbing our constraint locator, the locator named CP constraint POS position. Then we'll want to control click the group we've just made and apply a point constraint. Now watch this. As the character travels along the surface, no longer will he interpenetrate. So this is really cool stuff. Now, something you want to keep in mind is that you'd want to keep your resolution on the surface a bit high. If it was a low surface, well, we'd still run into a lot of intersecting simply because there's not enough resolution there to prevent it. So that's, again, something you'd want to consider. But either way, it's a great constraint to use, again, for finding points along a surface. And in our case, we used it to help prevent interpenetration and to make sure that our character moves along the surface even as it deforms.